It's one of the most mysterious aircraft on Earth, a black triangle that glides through the skies like a shadow. No vertical tail, no visible engine exhaust, almost completely undetectable to radar. The B-2 Spirit stealth bomber isn't just a plane, it's a flying ghost. Capable of reaching any target on the planet in a single flight, the B-2 can deliver nuclear or conventional weapons without ever being seen. It's a marvel of stealth, aerodynamics, and military engineering, and it's built under a veil of secrecy so thick even the factories where it's made are shrouded in classified protocols. But today we're pulling back the curtain. From composite materials to stealth coatings, from hidden engines to radar-evading curves, this is how the B-2 Spirit is made. Part 1. Designing a Flying Shadow. The design of the B-2 Spirit didn't begin with speed or firepower. It began with a question: how do you make an aircraft that can't be seen? To do that, engineers turned to radar, specifically how to avoid it. Most aircraft reflect radar signals back to their source, but the B-2's shape deflects them away. That meant ditching the traditional fuselage and tail. Instead, they adopted the flying wing design. A smooth, wide delta with no vertical stabilizers and no sharp edges. But shape alone wasn't enough. Engineers at Northrop Grumman layered in special materials, carbon graphite composites, radar-absorbent resins, and dielectric coatings. These don't just resist radar, they literally absorb it. Imagine trying to shine a flashlight at a wall that just swallows light. That's what the B-2's surface does to radar. Every curve, every panel, even the bolts had to be designed with radar in mind. Seams are minimized, edges are curved, and access panels are flush to the body. And when those panels are installed, they're sealed with a special tape made of ferrite particles suspended in flexible polymers, a detail that remains classified to this day. Part 2. Building the Invisible Frame. The B-2's airframe isn't built in one piece. Instead, it's manufactured in modular sections: center fuselage, left and right wings, and the forward cockpit segment. Each is built in ultra-secure facilities where workers undergo intense security screenings. In many areas, even they don't know what other teams are doing. Compartmentalization is part of the secrecy. The structure begins with carbon fiber reinforcement. These fibers are laid out in massive molds and soaked in epoxy resin. They're cured in autoclaves, giant pressurized ovens, at precise temperatures. The result is a rigid, ultralight composite skin that's strong enough to support the aircraft at 50,000 feet, but light enough to reduce radar reflection. Next, titanium spars and frames are added to support high-stress regions like landing gear and bomb bays. These titanium parts are milled using 5-axis CNC machines that cut metal down to tolerances thinner than a strand of human hair. Even the screws and rivets are made from non-reflective alloys. Every hole is countersunk, filled, and sealed with radar-absorbent putty. When viewed under radar in testing chambers, the fully assembled skin reflects no more than a small bird. Part 3. The Secret of Stealth Coatings. The B-2's signature black coating is more than just paint, it's science. A multi-layered system known in the defense world as RAM, radar absorbent material. First comes a primer layer that binds to the composite frame, then technicians apply the RAM coating. This includes ferromagnetic particles and carbon-based polymers that disrupt radar wavelengths. Even the exact formulation of the paint is classified. Workers apply this coating by hand in climate-controlled clean rooms. The temperature, humidity, and air pressure are all carefully maintained. Any contamination, dust, lint, even sweat can ruin the stealth effect. The coating is applied in overlapping passes with hand rollers and electrostatic sprayers. Then it's cured under infrared lamps, examined under special radar simulation lights, and tested in miniature anechoic chambers to ensure it works. This isn't a one-time process either. Every B-2 must be recoated periodically, and damage must be repaired instantly. Even bird droppings can compromise stealth, which is why the aircraft is often kept in climate-controlled hangars, nicknamed cocoons. Part 4. Hidden engines, hidden heat. The B-2 uses 4 General Electric F118-G E-100 turbofan engines. But here's the trick, they're buried deep inside the body of the plane. Most jets have exposed engine nacelles and exhausts, which create radar and heat signatures. But the B-2's engines are hidden in S-shaped ducts buried within the wings. These ducts are lined with radar-dampening material and coated with thermal-resistant ceramic tiles. This design does 2 things. First, it cools the exhaust air before it leaves the aircraft, minimizing infrared signature. Second, it hides the turbine blades from radar view. Turbine fans are normally a radar giveaway, but on the B-2, you can't see them, even from below. The exhaust is then expelled through wide, flat vents on top of the wing, further diffusing heat. It's the reason the B-2 can fly over radar-equipped missile systems without being detected. Each engine is installed with layered shielding, soundproofing, and sensor wiring, and they're connected to an onboard computer that adjusts thrust and airflow for efficiency and stealth on the fly. Part 5. Brains behind the shadow. Stealth alone won't keep the B-2 in the air. Unlike conventional jets, it has no tail to stabilize it, so stability is achieved through software. The B-2's fly-by-wire system is constantly making micro-adjustments, hundreds per second, to keep the aircraft level, even in turbulence. The pilot inputs the desired direction, but the computer decides how to move the control surfaces to achieve it. Inside the avionics bay, fiber optic cables carry information from sensors embedded all over the aircraft. These sensors monitor everything: wind, temperature, radar reflection, structural stress, engine heat, even vibration. All of it is processed by multiple redundant flight control computers. Navigation is handled by a mix of satellite GPS and an internal inertial guidance system that can fly blind if GPS is jammed. Communications are encrypted and often silent. In stealth missions, the B-2 can fly across the globe without ever transmitting a signal. And then there's the payload. The B-2 carries nuclear and conventional bombs inside 2 internal bays. The bay doors open and close in just a few seconds, fast enough to drop the payload and seal up before radar can register the change in shape. Part 6. Final assembly and test flights. When the modules are complete, they're transported, often under armed guard, to a central final assembly facility. Here, engineers bond the wings to the fuselage using aerospace-grade adhesives and titanium bolts. Once the structure is unified, the stealth skin is checked again. Every surface is scanned by mobile radar dishes. Technicians use radar-absorbing filler to smooth out any irregularities. Then come the test flights. First, taxi tests on the runway to check stability and braking. Then low-altitude circuits to verify controls. Finally, long-range stealth flights across instrumented ranges, where radar installations attempt to detect it. During these flights, engineers gather thermal, acoustic, radar, and structural data. If even one system underperforms, the plane is returned to the hangar for rework. The B-2 Spirit isn't just a plane, it's a statement, a demonstration of what happens when engineering, secrecy, and precision converge. It took over a decade, billions of dollars, and the minds of the most elite aerospace engineers in the world to create it. Only 21 were ever built. But despite being over 30 years old, the B-2 is still one of the most advanced aircraft in the sky. Invisible, untouchable, always ready. Want to explore more machines like this one? Hit the like button, subscribe, and comment below what you'd like to see next. We'll see you in the next one.